Hello guys, my name is Dylan. My YouTube channel is JG Bros, and today we are going to be doing the sine and cosine 4. Okay, so what we're going to do is we're going to come here in the middle, and we're going to draw seven lines down. So 1, 2, 3, so point 1, 2, 3, 4, 5, 6, 7. Okay. We're going to have our compass right with us, and we're going to adjust our compass so that it fits with those 7 lines. And then we're going to do what we do with compasses. We're going to draw a circle. It's okay if you make a mistake, like I did. So don't retract your compass. And so what we're gonna do is we're gonna draw a couple lines. Okay. So I would get out a ruler, and we're gonna draw a horizontal line going through the center. Okay. And then we're going to draw a vertical line going straight through the top. Okay. And now we're going to draw a line that looks something like this. It doesn't have to be exact, but it has to be somewhat like this, okay? And then we're going to go to this corner, draw a line going down, okay? You can put your ruler to the side. So this is a review, and so this is a unit circle, okay? Now in this circle there are 4 quadrants, okay? Quadrant 1, quadrant 2, quadrant 3, and quadrant 4, okay? And so, the first quadrant, the x numbers, the x-axis, this is the x and this is the y. The x-axis on this side is positive. And then the y-axis on this side is positive. And then the x-axis on this side is negative, and the y-axis on this side is negative. Okay? So, as you know, this part right here is the cosine of theta. Okay? And so the arc length is theta radians of x. So the sine of theta is almost always a fraction of 1, and the cosine of theta is almost a fraction of 1. So let's draw a table. So this is going to be a big table. So let's place down our ruler. Okay. Now we're going to make 4 lines. Try and make them about equal space. They don't have to be perfect. Make sure they're nice and long. Okay, so now we're going to fill in our chart. So, the first one is theta degrees. Second one, theta radians. The third one, decimal radians. So I'm just going to say DECRRA. Dec radians. This means DEC means decimal. And so we're going to have the sine of theta and the cosine of theta. Okay? So we're going to have 0, 30, 45, 60, 90. 45, 60, 90, 120, 180, 360. Okay, so we need to make this a little bit longer. Okay, and so the radian of 0 is 0 degrees is 0. Okay, and 30 is pi over 6. 45 is pi over 4. 60 is pi over 3. 90 is pi over 2. 180 is pi. 360 is 2 pi. Okay? So far your chart should look like this. So, what we're going to do now is you're going to do the decimal radians. So, the decimal radian is 0, 0. Decimal radian of 30 is 0.523. Decimal of 45 is 0.785. Decimal of 60 is 1.04. Decimal is 90 is 1.57. Decimal of 180 is 3.14. Decimal of 360 is 6.28. Okay? Now let's do the sine of theta. So the sine of theta of 0 is 0. Sine of theta of 30 is 1/2. 45 is 1 over the square root of 2. 60 is square root of 3 over 2. 90 is 1. Do you see it, why 90 is 1? Well, if you don't, we'll look up back at our unit circle. So if the sign is getting bigger, then this is moving up. Okay? And it goes up. When it reaches 90, let's imagine this, let's say this is 1 up here. Right here is 1. Okay? When it reaches 90 degrees, it's going to be at 1. Okay? And now, 180. Now this one is a little bit more confusing. It's 0. Because, let's look, 90 plus 90 is 180. So, 180 is half. So it moves up all the way to down here. this is 0. Let's say this is 0. It goes up to 0. Okay? And then 360 is also 0. You know why? Because 360 degrees is all the way around. When we get back here, we're back at 0. Okay, now the cosine. So the cosine of 0 is 1. Okay? And the cosine of 30 is the square root of 3 over 2. Cosine of 45 is 1 over the square root of 2. Cosine of 60 is 1 over 2, or 1/2. Cosine of 90 is 0. Cosine of 180 is -1. And cosine of 360 is 1. Okay? So that is our review. And then we're going to move on to our second topic. This one is general triangles. So we're going to get out our protractor. And put it right here. And so we could put our dot here. And we're going to draw a triangle from here to the thin red line. So we're going to draw it like from here to here. And then we're going to put our angle. Okay. And then where our point is, we're going to draw a circle. It's going to go right okay. So now we have our unit circle. Okay. So we're going to label our point. So this side is called the hypotenuse. So we're just going to put it HYP. Now this side is the opposite. So OPP. It's the opposite because if theta's here, opposite side. And then this side is the adjacent, ADJ. Okay? Now we're going to do what we did earlier and draw our line in here. Okay? And then we're going to label these points. So this point is called O. And then this point is A. This point is B. This point right here is, this point is C. And then this point down here is D. Okay? So what we know from a previous video is that triangle OAB is similar to ODC because they both have right angles and the common angle theta. From a previous video, we know that the sine of theta over 1 equals the hypotenuse, but the opposite over hypotenuse. So OPP over hyp. Okay? And the cosine of theta over 1 is equal to the adjacent over the hypotenuse. Okay. And so, what we can do is that the hypotenuse times the sine of theta over 1 equals the opposite over the hypotenuse times the hypotenuse. And these cancel out. So then we can do the same thing on the other side. The hypotenuse times the cosine of theta over 1 is equal to the adjacent side over the hypotenuse times the hypotenuse. And these cancel out. So we're left with the hypotenuse times sine of theta equals the opposite. Okay, this is going to be a key, and this is going to start our next video. And so the next one is the hypotenuse times the cosine of theta equals the adjacent. I hope you guys enjoyed this video. Thank you so much for watching, and I hope I'll see you guys next time.